Good morning, dear students. Today I am continue to the previous lecture. Now I am discussing the Legendre homogeneous differential equation. I am discussing in a previous lecture Cauchy-Euler homogeneous linear differential equation, and now the second type of the differential equation is Legendre homogeneous differential equation. First of all, you can note down the topic Legendre homogeneous differential equation homogeneous differential equation Legendre homogeneous differential equation. Let a differential equation is the form of a plus b x to the power n dny of dxn plus a1 a plus b x to the power n minus 1 dn minus 1 y of dxn plus so on plus a and y is equal to capital X, where a naught comma a1 comma a2 dot an are constant and x is the function of small x. The equation, this is equation number first. In this equation is known as Legendre equation. The equation first can be reduced in linear differential equation form. First, I am let a plus bx is equal to e to the power z, or you can simply write z is equal to log a plus bx, or x is equal to e to the power z minus a upon b. Now you first find the value of dz of dx. You can write differentiate of this with respect to x. You can write b upon a plus bx. This is a value of dz of dx. Now, first of all, you find the value of dy of dx. Now you can write this dy of dz into dz of dx. Put the value of dz of dx. You can write dy of dx is equal to b upon a plus bx into dy of dz. Now you can write a plus bx dy of dx is equal to b dy of dz, or you can simply write a plus bx dy of dx is equal to b into capital dy, where d is d is known as the differential coefficient, or is equal to d of dz. Now second, find the value of d2y of dx2. You can write d of dx bracket dy of dx. Now, putting the value of dy of dx, you can write d of dx bracket b upon a plus bx into dy of dz. This is a differential of first into second u into v. Now you can putting all the value of u into v. First you can write b a plus bx d of dx into dy of dz. Now minus b square upon a plus bx to the power 2 into dy of dz. Now you can solve this function. You can write b upon a plus bx. You multiply of this function. You can write dy of dz into, you can write dz of dx you can write d2y of dz2 dz2. Now minus b square upon a plus b x to the whole power 2 dy of dz. Now put the value of dz of dx, dy of dz of dx, dz of dx. You can write b square upon a plus bx to the power 2 into d2y of dz2 minus b square upon a plus bx to the power 2 into dy of dz. Now you can write a plus bx to the power 2 d2y of dx2 is equal to b square d2y of dz2 minus dy of dz. Now you can simply write b square d minus 1 y. This is a second derivative of the Legendre function. Please, you can note down both function of. This is a solution of the Legendre form to convert the linear differential equation. Put all the value of dz of dx and a plus bx dy of dx. Put the value of this. And now second is a plus bx to the power 2 d2y of dz. Put the value of this. This equation number 1, can be reduced in the linear differential equation form. First of all, you can note down this topic and this solution of differential equation. Now I am continue to use the numerical problem in this function. So this topic, Legendre homogeneous differential equation. First of all, you can note down the example number first. Example number first. Find the solution of differential equation if you can note down numerical problems. 3x plus 2 to the whole power 2 d2y of dx2 plus 3x plus 2 dy of dx minus 36y is equal to 3x square plus 4x plus 1. This is your numerical problem. First of all, you can note down solution of this problem. We have 3x plus 2 to the whole power 2 y double dash plus 3x plus 2 y dash minus 36 y is equal to 3x square plus 4x plus 1. This is equation number first. Since the given equation first is Legendre form, Legendre differential equation, differential equation. Therefore, let first of all let 3x plus 2 is equal to e to the power z, or you can simply write z is equal to log 3x plus 2, where e to the power z is equal to, sorry, x is equal to e to the power z minus 2 by 3. First of all, I am finding the value of dz of dx. First of all, find the value of dz of dx. Now you can differentiate of with respect to x. You can write 3 upon 3x plus 2. Now second is find the value of dy of dx. Now you can write 3x plus 2 dy of dx. You can write b means 3, dy. Now third is 3x plus 2 to the power 2 d2y of dx2. You can write b square, this means 9, d minus 1 y, where capital D is equal to d of dz. This is a differential coefficient. Now putting all the value in the equation first. Putting in equation first. Reduce the Legendre differential equation in a linear differential equation form. You can put all the value of this. You can write 9 d minus 1 y plus 3 into 3 dy minus 36 y is equal to, put the value of x. You can write 3 into, put the value of x, this is e to the power z minus 2 upon 3 to the power 2 plus 4 e to the power z minus 2 by 3 plus 1 plus 1. Now you solve this equation. You can write 9d square minus 90 will be cancelled, minus 36 y is equal to, you can solve this, 1 by 3 e to the power 2z plus 4 minus 4 e to the power z plus 4 e to the power z minus 8 plus 3. You can write this equation. You can solve this equation. You can write 9 d square minus 4 y is equal to 1 by 3. You can solve this, e to the power 2z minus 4z minus 4 e to the power 4z will be cancelled, and this is minus 1. This is equation number second. This equation is a linear thing, hence the equation second is linear differential equation. Now I am solving the linear differential equation. I am converting this equation to the linear differential equation. This means Legendre differential equation, Legendre homogeneous differential equation. Now the solution of this problem, this differential equation. Now first of all, you can find the AE. This means auxiliary equation. This means AE. You can write m square minus 4 is equal to 0, where m is equal to plus minus 2. There is a two different roots of m. First is plus 1 and second is minus 2. First is plus 2, second is minus 2. You can write the CF of this equation. You can write C1 e to the power 2z plus C2 e to the power minus 2z. This is your CF. This is your CF. First of all, you can note down all the value of this equation. You can reduce the Legendre differential equation in the form of linear differential equation form. Use this method. Continue to this step. Please, you can note down. The next step is find the PI. PI. You can write PI is equal to 1 upon d square minus 4 into 1 upon 27 e to the power 2z minus 1. Now you can write 1 upon 27 into 1 upon d square minus 4 e to the power 2z minus 1. Now you can write 1 upon 27 1 upon d square minus 4 e to the power 2z minus 1 upon d square minus 4 e to the power 0z. Since you can write the value of 1 is equal to 0, z e to the power 0 is equal to 1. Now you can solve this 1 upon 27. Put the value of z. This means if you can put the value of 2, this is equal to 0. Now first of all, you differentiate of this function. You can write z into 1 upon 2d e to the power 2z. Now you can put the value of 0. This means 1 upon minus 4. Now you can solve next step. You can write pi is equal to 1 upon 27. Put the value of e to the power z. This means d is equal to 2. Now you can find z into e to the power 2z upon 4 minus plus 1 by 4. Or you can simply write the pi is equal to 1 upon 108 z into e to the power 2z plus 1. This is your pi. Now the solution of differential equation second, y is equal to cf plus pi. Put the value of cf is equal to c1 e to the power 2z plus c2 e to the power minus 2z plus 1 upon 108 pi. This means z into e to the power 2z plus 1. Now where z is equal to log 3x plus 2. Now the solution of y is equal to c1. Put the value of e to the power z. This means e to the power z. This means 3x plus 2 to the power 2 plus c2. Put the value of e to the power minus z. This means 3x plus 2 the whole power minus 2 plus 1 upon 108. Put the value of z. This means e to the power. First of all, put the value of e to the power z. This means 3x plus 2 to the power 2 into z. This means log 3x plus 2 now plus 1. This is a final solution of the differential equation first. This is a solution of differential equation first. This is a solution of differential equation, Legendre differential equation. Legendre homogeneous differential equation. This is a solution of Legendre homogeneous differential equation. First of all, you can note down all the steps of this numerical. This is a very important numerical and relation of the homogeneous differential equation with linear differential equation. You can note down. Find the solution of differential equation. You can note down the differential equation. X square d2y of dx2 plus 6x dy of dx plus 6y is equal to x square into log x. This is a differential equation. First you can write solution of this problem. We have x square y double dash plus 6x y dash plus 6y is equal to x square y. Since the given equation is Cauchy-Euler homogeneous linear differential equation. This equation is, since the given equation is Cauchy-Euler homogeneous differential equation, then can we reduce in linear differential equation form. First of all, you let x is equal to e to the power z, or you can simply write z is equal to log x, and first of all find the value of dz of dx. You can write 1 by x. Now the second, find the value of x dy of dx. You can write dy, and second is x square d2y of dx2. You can write d minus 1 y, where capital D, this is a differential coefficient. You can write d of dz. Now you can let, this is equation number first. Putting the value of these value in equation first, you can write d minus 1 y plus 6 dy plus 6 y is equal to, put the value of x, this means e to the power 2z. Now put the value of log x, this means z into e to the power 2z. Now you can write d square plus 5d plus 6y is equal to z into e to the power 2z. This is equation number second. The equation number second, is linear differential equation. Therefore, the solution of this equation, first you can find the value of AE. This means auxiliary equation. Now the auxiliary equation of equation second is m square plus 5m plus 6 is equal to 0. Now the factor of this function, you can write m plus 2, m plus 3 is equal to 0, where m is equal to 2 roots minus 2 and minus 3. The two root of the auxiliary equation is minus 2 and minus 3. Now you can find the value of CF. Now CF is equal to, there is two different roots of the m, therefore C1 e to the power minus 2z plus C2 e to the power minus 3z. This is your CF. Now second, find the value of Pi. This means particular integral. Pi is equal to 1 upon d square. You can write d plus 2 d minus plus 3 into z e to the power 2z. Now you can solve this. First of all, put the value of d. This means 2. You can write e to the power 2z 1 upon d plus 2 plus 2 d plus 2 plus 3 into z. Now you can solve this function e to the power 2z 1 upon d plus 4 d plus 5 into z. Now you find the value of pi. You can write pi is equal to e to the power 2z 1 upon multiply of this value. You can write d square plus 9d plus 20 z. Now you can write e to the power 2z upon 20. You have common the value of this function is 20. Now you can write 1 plus d square plus 9d upon 20 whole inverse into z. Now you can open the function of 1 plus x to the power minus n. You can write 1 minus nx plus n plus 1 x upon 2 x square plus minus dot dot dot. Now you can express this function. You can write pi is equal to 1 up e to the power 2z upon 20 1 minus 1 upon 20 9d plus d square into z. Now the next term will be 0 because the value of z to the power n is equal to only z. Now you can differentiate of this function e to the power 2z upon 20. Now multiply of z, this means z 1 by 20 9 into 1 minus plus 0. Now you can write the pi is equal to e to the power 2z upon 20 z minus 9 upon 20. This is your pi. This is your pi. You can note down the value of pi and cf. First of all, you can note down all the steps of this numerical. This is related to the Cauchy-Euler homogeneous linear differential equation. Next, I am converting the equation number 2 in a linear differential equation. First of all the differential equation you can write the linear differential equation form. If you have not write to reduce this method. So this step, this is a pi and this is cf. Now the solution of differential equation second, you can write y is equal to cf plus pi. You can write the value of cf c1 e to the power minus 2z plus c2 e to the power minus 3z plus pi is equal to e to the power 2z upon 20 e to the z minus 9 upon 20, where if the solution of equation first, you can write z is equal to log x. Now the solution of differential equation Legendre Cauchy Euler homogeneous differential equation. You can write y is equal to, put the value of z, it means e to the power x. This means you can write c1 x to the power minus 2 plus c2 x to the power minus 3 plus e to the power z. This means x square by 20. Put the value of z, it means log x minus 9 upon 20. You can simply write y is equal to c1 upon x square plus c2 upon x to the power 3 plus x square upon 20 log x minus 9 upon 20. This is a solution of the equation number first. This is a Cauchy-Euler homogeneous differential equation. First of all, you can note down this numerical. This is very important.